AP Chemistry question of the day, January 4th, 2013. In a molecule in which the central atom exhibits sp3d2 hybrid orbitals, the electron pairs are directed to the corners of A, a tetrahedron, B, a square-based pyramid, C, a trigonal bipyramid, D, a square, and E, an octahedron. And I fixed the spelling on C, trigonal bipyramid, that should be an I. sp3d2, this falls under the category of VSEPR. VSEPR is valence shell electron pair repulsion, which says that when an atom bonds with another atom, the electrons are not going to stay in their, let's say, their s orbitals or their p orbitals and bond that way for the most part. They usually will form some kind of hybrid orbital of equal energy. So in this case, what they're saying, the hybridization is sp3d2, which means that there are 6 orbitals altogether, because this is actually an implied one. There are 6 orbitals that are all of equal energy. Let me just go over that again. It's a hybridization consisting of an amalgam, a mixture of 1s, 3 p's, so that makes 4, and 2 d's, which makes 6. So we've got 6 equal energy sp3d2 orbitals, and in the most basic case, they each contain in that atom 1 electron. Because what that atom will then do is bond with another atom, or a multitude of atoms that can each provide an electron to share with the central atom. Now there are cases where there are lone pairs and multiple lone pairs, etc., but in the most basic case, it is an atom that in the process of bonding, it doesn't exist like this normally, but in the process of bonding, the electrons will spread out into this hybridization. And the reason they do that is because it's electron pair repulsion, valence shell electron pair repulsion. Electrons are negatively charged, they repel each other, so they're going to fill out the space around that central atom in such a way that they are furthest from each other as possible. So we have a chart here, which I can provide for you. And in this chart, it shows you the shapes that these steric numbers would take up. So if you have a central atom with 6 what I call thingies coming out of it, or 6 hybrid orbitals, it's going to take up an octahedral shape. Of course, if one of those were occupied by a lone pair, it'd be square pyramid, 2 lone pairs, square planar, etc. But the most basic shape, you've got something with 6 that has 6 bonding places, a hybrid orbital that has 6 hybrid orbitals to bond. It's going to form the shape of an octahedron. So the correct answer would be E, an octahedron. I have a number of videos on, or actually one main video on VSEPR theory that explains it all. It's actually a pretty basic memorization thing for AP Chemistry. You just need to memorize your steric number, which is the number of, my fancy word for this is the number of thingies coming out of an atom. For example, let me do one example while we're talking about it. Let's say water. Water consists of 2 hydrogens, and we know those are 2 valence electrons because each hydrogen has 1 valence electron, and oxygen, which has 6 valence electrons. So we're dealing with 8 electrons altogether. We have oxygen in the middle, hydrogen on each side. They each form 1 bond. Each bond is 2 electrons, right? So now I have 4 electrons left, and they go like this. And everybody has a full outer shell because we know that hydrogen is full with only 2 electrons. So hydrogen here would have a steric number of 1. This has only got 1 thingy coming out of it, but we're not really interested in hydrogen as much as the central atom in determining geometry. Oxygen actually has 4 thingies coming out of it. It's got the bonds, but it's also got these lone pairs. So we look at it for a steric number of 4. Steric number 4 with 2 lone pairs, and we get a bent or angular shape, which is less than 109 degrees. I believe it's about 104.5 degree bond angle between the 2 hydrogens in water. So that will determine its shape. So these things just have to be memorized, and in Countdown to a 5 we actually have all of these made as flashcards so you can memorize the shapes based on steric numbers and lone pairs. Thank you very much, and tune in tomorrow for tomorrow's AP Chemistry question of the day.